Hello everyone, welcome back. Guys, today in this video we will discuss load balancing in HSRP. So topic for the day is load balancing in HSRP, and as you know, HSRP does not support load balancing, right? But if you want to perform load balancing, you can do that with the help of multiple group. You can create multiple group. In last video I had discussed each and everything about HSRP protocol. If you haven't watched that video, first of all you should watch that video. Go to my YouTube channel, and there you will find one playlist with the name FHRP. In FHRP playlist you will find HSRP video. So first of all you need to watch that video, then you should watch this video. Okay, so without wasting our time, let's begin. First of all, let me describe this topology to you. As you can see over here, I have connectivity from three ISP, from three different ISP, from ISP1, ISP2, ISP3. In real time you will take connectivity from ISP in same way, right? You will never connect, you will never take connectivity from same ISP, because what will happen if ISP will goes down? Suppose there is no ISP to ISP3, I have three connectivity from same ISP. And if ISP will goes down, my LAN user will never access internet, right? So you will never take more than one connectivity from one ISP, okay, in real time. So here you can see I have three connectivity from three different ISP, right? Here between router 1 and router 3 I am running this network. Between ISP1 and router 1 I am running this network. Between ISP2 and router 1 I am running this network. Between ISP3 and router 3 I am running this network, right? Now see, my requirement is what? I want to perform load balancing. What I want, that suppose in my LAN there are 300 user, 300 computer are connected in this LAN. Suppose for 100 user, R1 is my primary link, right? Suppose here bandwidth is 8 Mbps, here bandwidth is 4 Mbps, and here bandwidth is 2 Mbps. So for these 100 user, or you can consider for 200 user, R1 should be active router, right? Means all the traffic of 200 user should reach to internet via R1. But if R1 will goes down, automatically my default gateway will be shifted on router 2. If R2 will goes down, on R1 will come up. Sorry, if R1 and R2 both router will goes down, then my default gateway will be R3. Then all traffic should reach to ISP via R3. But if R1 will come up, automatically R1 will become active for these 200 LAN user. So here we will configure preemption, right? In last video we had discussed that thing. Okay, for next 50 user, suppose here we have 50 user. For next 50 user, R2 is my primary link, right? So all traffic of these 50 users should reach to internet via R2. But when R2 will goes down, so traffic, my default gateway will be R1. So all the traffic of these 50 users should access internet via R1 if R2 will goes down. And if R2 will come up again, so again default gateway will be this one. This one will become active router. Okay, so here if you want to perform load balancing, right? Here if you want to perform load balancing in the same way, for this user my primary link will be R3. If R3 will goes down, my active router will become this one, router 2, and this router will be in listening state. Okay, so here guys we need to create three group, because in single group we can't perform load balancing in HSRP. As you know, HSRP does not support load balancing. So here we will create one group. First, suppose group number 1, and virtual IP address of this group is 192.168.10.100. Just suppose 10.100, or you can consider 50, 10.50, fine, or let me consider 100, fine. And here I will set priority 100, not 100. Here I will set priority 100 10. So R1 will become active router, and here I will set priority 105 and here default priority 100. So R1 will become active router for group 1, right? So if you will define this IP address as default gateway to PC1, PC1 will access internet via R1. If R1 will goes down, this router will become active, because when I will set priority 100 over here, this router will become active, this router will become standby, and state of this router will be listen, right? So when active will goes down, standby will become active, right? Okay, then we will create one more group number 2, and here I will define IP 192.168.10. Suppose 200, and here I will set priority 105. Here on R2 I will set priority 110, and here default priority. So router who have highest priority, that will become active router. So this router will become active, and this router will become standby, and the state of this router will be in listen, right? So when active will goes down, this router standby will become active. In the same way, I will create one more group number 3, and here I will configure IP 10.300, right? And I will set priority 100 over here, 105 over here, and 1110 over here. So this router will become active for group 3. This router will become standby for group 3, and state of R1 will be in listen for group 3, right? So on PC1 I will define this virtual IP address as a default gateway. On PC2 I will define this IP address as a default gateway, and on PC3 I will define this IP address, not 3.250. You can't configure 300, right? IP address in 1 octet IP address can be 02255, fine. So 250, okay, clear? So all traffic for R3 default gateway will be 10.250 and 10.250. 10.250 is a virtual IP address for group 3, and for group 3 which router is active? Router 3. So all traffic of this user will be go via router 3. On PC1 I will configure default gateway 10.100, right? So 10.100 is a virtual IP address for which group? For group 1, and for group 1 which router is active router? Router 1. So all traffic of PC1 will be go via router 1, right? Okay, on PC2 I will configure this IP address 10.200, and 10.200 is virtual IP address of which group? Of group 2. And for group 2 which router is active router? Router 2. So all traffic of PC2 will be go via router 2, right? But guys, before configuring HSRP I have to configure PAT over here, right? PAT, or we can configure NAT, right? Then only my LAN user can access internet, right? So first of all I will configure IP address default route on all routers, and then I will configure PAT, then I will configure HSRP. So I have already configured IP address on all router. Let me show you. So see, on ISP router, so IP interface brief exclude unassign. So here you can see IP address is what? IP address is on loopback interface 8.8.8, and on serial 2/0 IP address is 1.1.2, 1.1.1.2, right? So IP configuration on PC1 is fine. Now let me configure router 1, and here you can see I am going to create this group. Okay, group 1, group 2 and group 3. For group 1 I will set priorities 110 on router 1. For group 1 I will set priority 110 on router 1. I will set priority 105 on router 2. I will set priority 100 on router 3, and this is virtual IP address of group 1. This is group 2. Here I will set priority 105, here 1010, here 100, and this is virtual IP address on PC. On group 3, here on router 1 priority will be 100, on router 2 priority is 105, and on router 3 priority is 110, right? So with the help of these 3 groups we can achieve load balancing in HSRP, right? Or you can configure VLAN as well, right? According to VLAN as well you can perform load balancing, fine. So go to router 1 and let me configure router 1 first, config T, IP root 0.0.0, while subnet mask 0.0.0 and exit interface is serial 2/0. Right after that interface serial 2/0 IP NAT outside, this interface is outside, exit interface F0/0 IP NAT inside, and to configure PAT I have to create one access list. So access list suppose 10 and permit which network? My LAN network 192.168.10.0. wildcard mask is 0.0.255. Okay, after that IP NAT inside source, match source from list 10 and translate it into interface serial 2/0 IP address, right? And you need to add one key. So let me run no here and overload. Right now you can see I am able to ping. Sorry, I have getting some error. Dynamic mapping not found. Okay, so I have to configure again. IP NAT inside source, match source from list 10 and translate into interface serial 2/0, and you need to add one key. Overload. Now you can see ping 8.8.8.8. I am able to ping 8.8.8. Can I ping 8.8.8 from my LAN interface 192.168.10.1? Yes. Here on the LAN interface I am running IP address 10.1, here on 10.2, here on 10.3. Okay. On PC1 I will configure 10.10, 10.20 and 10.30, and these will be my virtual IP address. These IP address will be virtual IP address, right? So now let me configure PAT on router 2. PAT on router 2 command will be same, IP root 0.0.0, 0.0.0, and exit interface is serial 2/0, right? Interface serial 2/0, IP NAT outside, exit interface F0/0, IP NAT inside. Okay, access list 10, permit which network? My LAN network. My LAN network is 192.168.10.0, wildcard mask is 0.0.255. After that IP NAT inside source list 10 destination or translate it into interface serial 2/0 and overload. Remove this command, guys. No, overload. Okay, so ping 8.8.8.8. Yes, I am able to ping 8.8.8 and source 192.168.10.2. So my LAN interface can ping 8.8.8 internet, right? Let me configure PAT on router 3 first. So config T, interface serial 2/0, say IP NAT outside, exit interface F0/0, IP NAT inside, exit IP root 0.0.0, 0.0.0 and serial 2/0. Fine. Access list 10, permit 192.168.10.0, wildcard mask 0.0.255. Okay, IP NAT inside source list 10 interface serial 2/0. Okay, set. Okay, no problem, and overload. Fine. Ping 8.8.8.8. Yes, I am able to ping 8.8.8. Yes, can I ping 8.8.8 from my LAN interface 192.168.10.3? Yes, I am able to ping my LAN interface. So now if I will configure default gateway 10.1, over here. So PC1 can access 8.8.8 via R1 only. If R1 bill goes down, manually you have to change default gateway, right? So it's not possible to change default gateway again and again whenever default gateway will goes down, right? So I will configure HSRP. In last video we had discussed this thing. So go to router 1. First of all, let me configure HSRP on router 1. Interface F0/0, standby group number 1 and IP 192.168.10.100, right? Standby 1, let me enable preemption. After that, standby 1 priority is 1010. Fine. So standby. So you can see state of this router is active for group 1, right? Okay, let me create same group on router 2. Config T, interface F0/0, standby group 1 and IP is 192.168.10.100, right? Standby 1 preemption, standby 1 priority is 105. Fine. Exit. Let me create same group on router 3 also. Config T, interface F0/0, standby group number 1 and IP is 192.168.10.100, right? Standby 1 preemption, standby 1 priority is 100. Okay, so standby. So this router will become what? This router will become, state of this router will be in listening. And active router is, who is active router? Active router is 192.168.10.1 because priority of that router is 100, and standby router is 192.168.10.2 means router 2 because priority on router 2 is 105, right? So if I will configure default gateway, this virtual default gateway to PC1, right, 10.100, so all traffic of PC1 will be go via router 1. Let me configure IP 192.168.10.10 is, suppose this is IP address of this PC /24 and default gateway is 192.168.10.100, right? Now this PC can ping 8.8.8, ping 8.8.8.8. Yes, see, this PC is able to ping 8.8.8. If I will trace route, trace 8.8.8.8, see, my traffic is going via 10.1 means router 1. What will happen if router 1 bill goes down? Let me down router 1 interface. So config T, interface F0/0 say shut down. And now if you will trace route 8.8.8, so see, my traffic will be go via router 2. Now my default gateway is router 2, right? 10.2. When again router 1 will come up, say no shut, this router will become active. You can verify. So standby. So standby, state of this router is active. Now again PC1 will reach to internet via router 1. You can see 192.168.10.1. Okay, fine. Okay, now let me create one more group on these 3 routers. So first of all, on router 1, config T, interface F0/0, standby group number 2 and IP is 192.168.10.200. Standby 2 preemption preempt, right? Standby 2 priority is 105 here, right? On R2, let me configure same group on router 2 also. Interface F0/0. Standby group 2 IP is 192.168.10.200. Standby 2 preemption preempt. Standby 2 priority is 110. Fine. So this router will become active for group number 2. You can see the state of this router change from speak to active. Okay, on router 3, let me configure group 2. Config T, interface F0/0. Standby group number 2 and IP is 192.168.10.200. Standby 2 preempt, let me enable preemption. Standby 2 and priority is 105. Okay, so here I have configured what priority 110. Okay, so on router 3 I will set priority 105, not 105, 100 for group 2 na. Yes. Okay, so this is default priority, you don't need to run this command. Okay, now here on R1 or on R2, on any router you can verify. See, on R2 I am running this command. So standby. Till now you can see there are how many group? 2 group. This is group 1. For group 1 this router is standby, and for group 2, where is group 2? For for group 2 this router is active. For group 2 this router is active. For group 1 this router is standby, right? So whatever default gateway I have set in group 2, let me assign that default gateway to PC2. IP 192.168.10. Suppose 20 is the IP address of this machine /24, and default gateway is 192.168.10.200. So if PC2 will ping 8.8.8, can PC2 ping first? Yes, PC2 can ping 8.8.8. Let me trace route. If you will trace route, trace 8.8.8.8. See, traffic is going via router 2. If you will trace route from PC1, where is PC1? So PC1 is pinging 8.8.8 via router 1, and PC2 is pinging 8.8.8 via router 2, 10.2, right? And let me create one more group, that is group number 3. We'll go to router number 1 first. Standby 3 IP 192.168.10.250. Fine. Standby 3 preempt. Let me enable preemption, and we don't need to define priority here, because here I will configure default priority. Here priority will be 100. Okay, so now go to router number 2. Okay, so this is not router 2. Where is router 2? Okay, this one. Config T, interface F0/0. Standby group number 3 and IP is 192.168.10.250. Standby group number 3 preempt. Let me enable preemption, and standby group 3 priority is 105. On router number 3, so see, this router is active for group 3 now, but once I will configure group 3 on router 3, router 3 will become active, right? So standby group number 3 and IP is 192.168.10.250. Fine. Standby 3 preemption, standby 3 and priority is 110. So this router will become active for group number 3. You can see the log message, right? This router is active. Now if you will verify on R3, so standby. So standby. So see, for group 1, which router is active? Active router is 192.168.10.1. For group number 2, which router is active? 192.168.10.2, right? Because here priority is 100. And for group number 3, this router is active, right? For group number 1, which router is standby? Router 2. For group number 2, which router is standby? Router number 1. For group number 3, which router is standby? Router number, which router is standby? Router number 2. And active router is local. This router is active. So let me define this default gateway to PC3. IP 192.168.10.30/24 and virtual IP address is 192.168.10.250. Ping 8.8.8.8. See, I am able to ping. You can trace route, trace 8.8.8.8. See, traffic is going via router 3, right? So all traffic of this LAN user will be go via router 1, all traffic of this router will be go via router 2, and all traffic of this router will be go via router 3. But what will happen if router 1 will goes down? So traffic of this user will be go via router 2. What will happen if this router will goes down? Traffic of this user will go via router 2, right? So we have achieved load balancing, right? Let me down router 1. See, first of all, this is my router 1, and you can see PC 1 as well. This is my PC 1. Okay, let me down this interface. If you build trace route now, you can see all traffic is going via router 1. If router 1 will goes down, see, a traffic will shift on router 2, 10.2. Again, when my primary link will come up, say no shut, see, traffic will shift on router 1. See, 192.168.10.1. In the same way, on router 2 also you can check, sorry, on PC2 also. This is my PC2, and go to PC2, and where is PC2? This one. Okay, so now this user can access internet via where is router 2? Okay, now you can see PC2 is able to access internet via router 2, but what will happen if router 2 will goes down? Config T interface F0/0 say shut. Router 1 will become active router, yes or no? So you can see trace route. Now PC2 is forwarding traffic to router 1. Router 1 will become active router for PC2 now. See here, right? But again, when PC2 will come up, no shut. See, traffic is going via router 1, router 2, 192.168.10.2, right? So this is how you can perform load balancing in HSRP, right, guys? But what will happen if this link will goes down? So we have track feature, we can enable track as well. So go to router 1 and standby 1 track serial 2/0. So it will start tracking this interface, right, and decrement priority by decrement priority by 10. So if line protocol of serial 2/0 will down, it will decrement priority by 10. So for group 1, you can say for group 1, now I have configured what priority 110 and it will decrement by 10. So here priority will be 100. So this order will become standby and R2 will automatically become active. Okay, enter. See, so standby. So standby. So for group 1, this order is active and priority of this order is 110. 110 is configured and decremented by 10 if serial link will be goes down or line protocol of serial link will goes down. Let me down serial link. Interface serial 2/0. Say shut down. Do standby. Do so standby na. So see here, now priority is what? On group, for group 1 priority is what? 100, right? Configure priority is 110, but line protocol of serial 2/0 is down and decremented by, priority will be decremented by 10. So here priority is 100. So which router is active now? Router 2 is active now, right? But again when this link will come up, say no shut, it will increment priority by 10. Do so standby. See, now again priority is 100 and this router is active. Okay, so like this you can configure track for every group on all routers, and if you want to track 8.8.8 or ISP1, because if ISP will go down or 8.8.8 will goes down, suppose when 8.8.8 will go down, let me down 8.8.8 interface loopback 1, say shut down. Now 8.8.8 is not reachable, but still my PC will forward traffic to router 1, ping, or you can say trace route, trace 8.8.8.8. So PC is forwarding traffic to router 1, right? But router 1 don't have. Router 1 will forward to ISP because router 1 have default route, but ISP is down, right? So this user cannot access internet and their traffic will be not shifted on ISP2. So what we can do, we can track ISP as well with the help of external track, with the help of IP SLA, like this. First of all, let me run no shutdown on ISP router. Let me up ISP. Okay, up. Right now on router 1, if you want to track 8.8.8, what you can do, you can create one external track. Suppose track number is 10 and IP SLA. I want to use this track with IP SLA or SLA number is 10. Okay, you need to create SLA, IP SLA 10, enter. Here we need to, I am creating IP SLA for ICMP echo to 8.8.8, right? And source interface will be serial 2/0, right? So I am telling to this router that ping 8.8.8 from serial 2/0 will be your source. And let me start this SLA, IP SLA schedule. Number is 10 and start time is now and life is forever. Okay, so if you will check track, So track, my track is up. My track is up because line 8.8.8 is reachable. Ping 8.8.8. So this is the reason why my track is up. But when track will goes down, right here you will see track is down. Let me down 8.8.8. Now you can see track is up now. This is HSRP track and this is external track. I am talking about this track now, right? So this track is, state of this track is up. But if 8.8.8 will goes down, if ISP will goes down, let's say shut down, so track will down. Track is still up. 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 Now track is down. You can see track is down. Again when 8.8.8 will come up, track will be up. No shut. This track will come up. Or we can set frequency, right? Delay is too much, but you can't modify SLA. Okay, no problem. Now I want to use this track with HSRP. So go to configure terminal, again interface F0/0, standby 1 and track number is 20. Fine. And decrement priority by 10, or you can configure according to your requirement and enter, right? So when this track will goes down, it will decrement priority by 10. So again priority will become 100, so R2 will become active. So if ISP will goes down, now you can see where is my PC1. This is PC1. Now I am able to trace route 8.8.8 via router 1. But if ISP will goes down, let me down the ISP, shut down, right? ISP down hua, track will be goes down, so track will be goes down, so track is up. Just wait, we can change frequency, right? It's taking some time. So what we can do, we can change frequency as well. Router 1, how track 10 is up here, interface is down, 8.8.8. yes, interface is down. Track is, now you can see on router 1 track is down. So if you will run command, so standby here, you can see for group 1 this router will become standby. For group 1 state is listen. State is listen because priority is what? Because priority on this router is 100. Configured priority is 110, but due to this track object is down, so it will decrement it priority by 10. So current priority is 100, right? So this router will become standby for group 1. For group 1 this router will become standby. Active router is this one, standby is this one, and priority is this one. Okay, so R2 should become R1 should become standby now. Okay, let me up the ISP, say no shut, and if you will trace route now from here, you can see PC1 can ping 8.8.8 via router 2, right? So I am performing load balancing. Let me run no shutdown command on ISP router. So when ISP will come up, track will come up. So track 10 will come up. It's down now. Just wait, guys. It will take some time. This is problem of GNS3 Or here also we can change frequency. See, now track is up, so standby. So this order will become active for group 1. Okay, fine. So this is how you can perform load balancing in HSRP. Guys, in next video we will discuss VRRP. Okay, so that's all for today. If you have any doubt, please let me know. In the same way, you can track ISP2 also, ISP3 also, right, with the help of IP/SLA. On every router we can run same command, track command, right? So in HSRP we can use inbuilt track as well or external track as well. We can configure external track as well with IP/SLA. So this is how you configure HSRP in real-time environment when you want to perform load balancing. Okay, so if you have any doubt, please let me know in chat. I will make one separate video on that, right, on your doubt. Don't worry. But if you like this video, if you don't have any doubt, please don't forget to like this video. Please hit on like button. If you haven't subscribed my channel, please subscribe this channel, and we will meet soon in next video. Till then, stay safe. Okay guys, bye bye. That's all for today.